All right, so I'm going to recap over this real quickly because the video apparently X'd out while we were gone. So we talked about what domain was. Domain was the input, which is your X values. Range was your output, which is your Y values. And then we discussed what the representation for the domain and range could be within a graph. So for our range, it's from the minimum Y value up to the maximum Y value that is graphed. So in this case, it was from 0 to 24. Hey, turkey, hush. So our graph is, or our inequality would represent 0 is less than or equal to y, which is less than or equal to 24. And then our range going from, our domain goes from left to right, starting at 0, and it ends over at 30. So it goes 0 is less than or equal to x, which is less than or equal to 30. And then the representations means you have to understand what your axes are labeled as. So your y is representing the volume of water in gallons, and that your x represents the minutes. So taking a look here at this problem, it says a 350-gallon tank full of water is draining at a rate of 25 gallons per minute. The graph represents the relationship between the gallons of water in the tank and the minutes that the tank has been draining. So gallons of water is representing our y, which is our range. The domain is represented by the number of minutes. So they're giving you the graph already. What they want to know is, based off of this situation, could these values be possible inputs? Okay, which one of the values would be a possible input versus which ones are not a possible input? So when we're taking a look here, if you notice, this graph is what we would call continual. It's connected, okay? Continual and connected. That means that even though I can pick a point on the graph from here to here, every value in between is a representation, okay? Here, when we have it very dotted, that means it's a specific value. Nothing in between would count, okay? It is that specific point to the next specific point, and so on and so forth. Okay, so anything in between them would not count as potential values. So when we're looking here, they're wanting to represent the inputs. Now remember, input is the domain. Input is the x value in this situation. So we're looking at these and seeing if they are possible x values represented in the graph. So in this situation, we know that our domain starts at 0. So x is greater than or equal to 0, or 0 is less than or equal to x. But we also know that x needs to be less than or equal to 14. So we're looking at these values and identifying if they fall between 0 and 14. Does 15 fall between 0 and 14? Yes or no? No. So that would be considered an impossible input. It would not work in this situation because it is larger. This is too large. What about 2.7? Does that fall between 0 and 14? Yes. So that is a potential. That works out perfectly fine. It is in between 0 and 14. Go ahead and take a look at the rest of the values, identifying which ones are candidates, which ones are possible inputs, and which ones are impossible inputs. All right, so taking a look, 0. Will 0 be a possible input in this situation? Yes, because of the fact that we can include it, it is the equal sign, so it has to be anything 0 to 14. Anything greater than 14 won't work, anything less than 0 won't work. But 0 is a possible candidate. What about -4? No, negative values are not going to work in this situation, which makes sense because can we have negative minutes? No, we cannot have negative minutes in this situation at all. Okay, so that is, it doesn't make sense. Can't have negatives. Can't have negatives. Okay, what about 10? Is 10 a possible input? Yeah, 10's a possible input, right? It's located right here. We do have the value of 10 represented on this graph. And then what about a half? Would half be a possible input? Yeah, anything that is greater than 0, but greater than or equal to 0, but less than 14, those would all work. So a half is going to be a possible candidate. Okay. Now, again, It's easy to figure them out when you have a line that is graphed. But when you have a situation like so, where it's not a line, it's dotted representation, then you have to be more specific. Yes. Oh, oops. Thank you. Thank you for fixing that for me. You get a positive behavior point. All right. Taking a look here. Taking a look here. Based off of the situation that we have here, she borrows $100 from her uncle to buy her supplies. She's going to graph the graph compares the number of haircuts and her profit as she works her way to paying her uncle back. So in this situation here, number of minutes, that's a continual value because there is something in between the minutes, right? You have seconds, you have milliseconds, you've got time that exists in between minutes. But here, number of haircuts, are there haircut values in between each haircut? No, you have one haircut or you have two haircuts. You don't have 1.5 haircuts, right? You cannot have fractional or decimal values of a haircut. So you have to make sure that you understand that. So in this situation, we know we can't have fractional values. We cannot have decimal values. Can we have negative amount of haircuts? No. So right off the bat, what values am I able to get rid of in this table? Hassan?
I have 2.7 and -4.
Very good. The 2.7, the half, the -4, these are not possible haircut values, okay? Again, we're talking about the domain, the input. Okay, now range, that's different when we're talking about profit or money. Yes, you can have decimal values for money. Yes, you can have fraction values for money. Yes, she does have negative representation of money. The reason she has negative representation for money is because she borrowed money first. Borrowing money puts you into a debt, which is negative. So those can be negative in decimal and fractional values. But haircuts cannot. We're talking about input, which represents the haircuts, the number of haircuts. So 2.7 is not possible. A half is not possible. -4 is not possible. It is possible for her to have 0 haircuts because that's before she ever started. She owed $100. That is a possible value. Yes, as she keeps giving haircuts, her profit is going to go up. So she is eventually going to be able to get to 10 haircuts, and eventually she'll be able to get to 15 haircuts. Those are all possible inputs that she will be able to obtain. So you're looking at these contextual situations and having an understanding of what works and what does not. Okay, go ahead and flip it on over to the back. Logan in Turkey. Stop talking. So I'm going to keep calling you Turkey. It's your new name. All right. In this situation, what I want you guys to do is you are going to graph the representation here. If it makes a little easier for you, you can skip to problem 4 first by writing out what the equation is. We'll write it together. You're then going to graph the equation. You're going to identify your slope and your y-intercept. So let's go ahead and come up with the equation first. A submarine is 900 feet below the ocean. That's the starting point. And then it's going to slowly start to ascend, which means it's going to increase in its depth. It's going to increase. It's going to go up at a speed of 150 feet every 10 minutes. 150 feet every 10 minutes. So when we're writing that down, that's 150 over 10. 150 over 10 comes out to what? 15. So it's 15 per minute. So we're starting off at a depth of 900 feet below the ocean. That means that our y-intercept is at -900. And then we're going to continue to go upward by 15 feet every minute, because it's 150 feet every 10. If we do 150 over 10, that comes out to 15 over 1, or just 15. That's our x. So we now have y is equal to 15x minus 900. When we graph it, what do we have to graph first, the 15 or the 900? 900, and it's a negative, so we're graphing it here on the y-axis at -900. Then we're going to go up 15 over 1 or up 150 over 10. Okay? Now, up 150 over 10 is going to take me halfway between the 900 and the 600. Up another 150 over 10 is going to take me to negative 600, and then the negative 600 for the y, the 20 for the x. So really it's 20 negative 600. And then you're going to keep going in that pattern until you stop here. Now, why am I saying that I have to stop there? Andreas?
It's sea level.
It's at sea level. Can the submarine go up in the sky? No. Once it gets to sea level, it's docked out. Okay? So it stops here. This is its stopping point. Now, I am going to connect them because it is moving at a continual rate. It does move at a continual rate, so I am going to connect those together. Now, our slope of the equation was what? Hassan? 15. And that 15 represents what? It represents how far you are ascending, how many feet you're ascending per minute. It's 15 feet per minute. The y-intercept is that negative 900. That represents the depth at the beginning. It's negative 900 feet for your depth at the very beginning of the submarine's trek. Okay, now here we're going to talk about something new, an x-intercept. So if a y-intercept is where we cross the y-axis, what do you think the x-intercept is? Jeffrey? Where you cross the x-axis. So where we cross the x-axis is at the point 60, right, located here. So this is at 60, and this represents how long it took us to be able to get the submarine to sea level. So it was 60 minutes to sea level. Now the range of the graph, again, the range is your minimum y to your maximum y. Your minimum y to your maximum y. So our minimum y is negative 900. Our maximum y was to the 0. So it's negative 900, and yes, it does include it to the 0. For our domain starts from left to right, starts at 0 minutes to 60 minutes. So starting at 0 minutes and then capping off at 60 minutes. There's our domain's range of values or potential interval of values. Okay, we're going to stop here because you do have to line up.